Hello, this is part 2 of the AOI. So part 1, we imported existing AOI and data type. In this video, we're going to follow up and actually create those. So if you haven't watched part 1, I suggest you check that out and sort of understand the function. It'll help follow along in this video. So let's jump in. User defined, right click. I'm going to create a new data type. The data type is going to be named heat zone. And we'll start creating our tags. So we'll have zone enabled and our data type. Give ourselves a little bit more room here. We'll say temperature set point, which will eventually come from the HMI when fully implemented. And we'll say actual temperature, which will come from a thermocouple eventually. And actual temperature range. This will be an indicator, current state, and heat. Let's see, controller output. This will be mapped to our physical output card, our address on our output card to control our SSR. And we'll say we need an over temp limit as an indicator to say we're over our max allowable value. If you remember from the last video, we was sort of simulating that. And we'll say low temp limit. Let's see, let's make that a real. Oh, sorry, we need to back up here. This should be the set point, not an indicator. Yeah, so over temp limit. Okay. So this is to be the actual temperature high. So this is the indicator that we are or we have exceeded or met our high to over temp range. We'll say this should be, let's see, actual temperature. Sure. Low, below our low limit. Oh, not low. Boolean. And we have set points valid. As stated in the first video, that could be handled on the HMI just with the input-output fields, limiting what they can input and driving the low and high limit off the tags, but we'll go ahead and sort of have a redundant check here in the PLC. Okay, so that should be all our tags for our data type. We can go through and put descriptions. You can later if you're following along. So let's apply that. And we should have that heat zone data type here. Okay, so now let's create our add-on instruction. So we'll say new add-on instruction, and this will be named AOI SSR controller. And let's just do ladder diagram. And we'll say open definition. Okay. So within this, we need to find our parameters. Let's see. We'll say zone data. The usage will be in out because we're going to be reading some information from the HMI and also updating some information or passing it back out. The data type will be of the one we just created, heat zone. So for the respective zone, we're going to pass its data in. Okay. We don't need any local tags for this application. Okay. So apply, okay. So from here, we'll open our logic up. Okay, let's start out. I like to start and give myself a comment line at the start here. It's just a habit. Okay, so we'll look. Let's start with a limit instruction to cross-check our zone data low limit. So if we go low temp limit real, we want it to be between 1 and the set point. Set point. And we want to make sure that the temperature set point is greater than 1. Be sure we have a value there. We'll just copy this. And we want to test also that our set point is between the low limit and the max limit. Let's find that here, set point over temp limit. And again, we'll paste, copy, paste. And let's test our low limit. As we need to test our over temp limit. And we're going to hard code a value here. For right now, I'm going to say 550 because we're going to set our over temp limit to 500. Again, this can be handled on the HMI, but once you sort of fine tune the process, you can come change these values, tweak these as you need, and that should be low limit set point. And then we'll say, so if all those conditions are true, all our set points are valid. Okay, so this will be our rung for our heater output control. So first we want to check to be sure this zone's enabled. And then we can say that all our set points are valid. And do not want to be you could say that I'm in range, or it's better to say that I'm not above the max range. Maybe cooling off, and maybe the weekend it's got to cool or heat up, excuse me. So as long as we're not above the max range. And we say, let's just copy this comparator instruction. We say, so we'll say our actual temperature is less than, grab this one, it's less than our low limit. Turn our heat on. So then we'll start heating up. So we'll have to latch that in. So condition's not true and the output is already on. And the actual temperature, as long as it's less than the set point. Okay, looks right. Okay. Okay, so we want to update our indicators for the process. So if our set points are valid, we can start comparing for those. So we've got 3. So let's go ahead and get these in here. So zone data, we've got a program for in range. We'll go ahead and drop, we'll just put all these in one here. Say we have one for temperature is high. Say temperature is low. Okay, let's see here. So if we go to compare, and in range, we're going to have to use this compare function for an expression. So I'll explain why. So if we say our actual temperature, actual temperature is greater than or equal to, let's see, where's our low limit? Low limit, and we want to give it a little buffer. So we're going to say -5. So as soon as the heater kicks on, we want to give it a few degrees to sort of get within the limit. So just, and it's just for an indicator. So we'll give it a little bit of buffer there. And we also want to say we can use a regular compare instruction for this. And we say our actual temperature is less than the over temp limit. Yep. Assumed to be in range. So if we say, let's grab another comparator, let's just drop that here. And we say the actual temperature is greater than, let's see, greater than or equal to the over temp. We are high limit. And again, we want to, if our actual temperature is less than the temp low limit -5, we are low. So we're below this band. We just got to be sure these two values match here. Okay, so that should have us covered on the AOI. Pretty simple function overall. It's just the point of it is that if you have 18 or 19 of these zones, you save all this programming. And if you viewed part one, that's really good. Thanks for watching. If not, I'm going to run through this real quick to drop this in our main program. So, okay, so if we go to main and we go to add-on instruction, we're going to drop our first zone. So in the first video, we sort of walked through the instance of this call. So I'm going to create that. And now we need to create our tags once again. And that will be heat zone with 20. So an array of heat zones, 20 of them, named zone data. And we'll create that. Zone data, we'll pick up number 1. Let's drop that here. And we'll go ahead and just add 2 more zones here. Like we did in the first video, create those instances. And these instances are really going to store that in out data. But for every call, it needs a separate memory area for that. Just so the code updates for its respective. What did I do? Oh, sorry. For the respective call. So now we're going to be sure we're passing the proper zone data of our array. This will be number 2. Okay. So it looks like everything's happy there. Everything's happy there. It's always a good sign. We'll go ahead and download this. Okay, and that's it. We tested the function in the first video of how the actual logic functions and also how to monitor this per the instance of the call. So you can monitor per the call. So if we wanted to just see barrel 3's code, we could. Or if we're having a problem with a set point or one good thing about this code, like I mentioned in the first video, is if you have a problem with this AOI, typically it affects them all. So it makes troubleshooting a bit easier to track down. Okay, so yeah, so a couple more videos upcoming. I'm going to use the same application, same principles in the Siemens platform and TIA. So how this AOI sort of fundamentally follows the function block in the Siemens processor. Thanks for watching.